Good evening, students. In the previous lecture, we have discussed about equivalent mass, and today we will discuss about important numericals based on equivalent mass. First question says that 2 grams of metal carbonate on decomposition gives 1.5 grams of metallic oxide, and they are asking calculate the equivalent mass. So, an important formula here, that is mass of metal carbonate by mass of metal oxide is equal to equivalent mass of metal plus equivalent mass of carbonate divided by equivalent mass of metal plus equivalent mass of oxide. Very simple. Numerator you have carbonate and denominator you are having oxide. Now important thing is we need to substitute the values here and then calculate equivalent mass of carbonate as well as oxide. First let us see here. Already we know E is equal to M by A, B, C and V. This we discussed. Here what will be the valency of carbonate? That is nothing but M by 2. What is the molecular mass of carbonate? C is 12, O3 48. So we have 60. So 60 by 2 nothing but 30. So equivalent mass of carbonate is 30. Second one for oxide. So M, that is nothing but 16 by valency 2. Here we have 8. Now in the first step we have calculated equivalent mass of carbonate as well as oxide. Now let us substitute. Given mass of carbonate is 2 grams and the mass of metallic oxide is 1.5 gram. So 1.5 we can also take it as 3 by 2. So let us write 3 by 2 such that 2 can be taken to the numerator so that we will get 4 by 3. If you write like that, it will be easy for calculation. Is equal to equivalent mass of metal, let us write it as E, and equivalent mass of carbonate we have 30. Now E plus for oxide, on calculation you have got 8. On cross multiplication what we get? We get 4 into E plus 8 is equal to 3 into E plus 30. Now 4E plus 32 is equal to 3E plus 90. Now let us send 3E to this side and 32 to the other side of equality symbol. We get 4E minus 3E, that is E is equal to 90 minus 32. So here we get 58. So the equivalent mass of the metal we got as 58. So remember this formula so that you can calculate this type of questions. Now second question. So equivalent mass is given and the valency is also given, and they are asking what is the mass of the single atom. So this is also very simple. Once again stick on to the basics. We know the first formula, that is E is equal to M by A, B, C and B. Now they are talking about valency. So therefore we can write like this. E is equal to M by valency. From this how do you get molecular mass? So molecular mass is equal to equivalent mass into valency. You can write E into V. So we have derived this formula. Now we can identify that this particular metal, if you are taking the 1 mole or molecular mass, what will happen? It will occupy, this will occupy Avogadro number. So Avogadro number you know 6.023 into 10 to the power of 23 atoms in this case. So now let us substitute this. They have mentioned equivalent mass is 31.82. So now if at all you are taking the molecular mass is equal to 31.82 into the valency is mentioned as 2. So this molecular mass will occupy 6.023 into 10 to the power of 23, or simply you can mention it as Avogadro number. Now let us write that if Avogadro number is occupying 31.82 into 2 here, that is the mass, what will be one atom weighs? So let us take it as x. I think you are able to follow this. First we have taken molecular mass, nothing but equivalent mass into valency. So if you take the molecular mass, it will have this many number of atoms. So we can identify very easily now, cross multiply. Therefore x is equal to 31.82 into 2 divided by Avogadro number. What is 31.82 here? Nothing but 63.64 by Avogadro number of grams. So the single atom will have the weight of this. Hope you have understood this. So in the next class we will discuss some other numericals based on equivalent mass. Thank you so much.